What up, guys? So welcome back to trigonometry, and on this video we'll be doing identities involving compound angles and double angles. So in the past we have done compound angles, and we have also done compound angles. We did double angle and compound angles. Now, what is proving the identity? It's those things where we need to prove that the left hand side of the equation actually equals to the right hand side of that equation. So let's just start with with some simple stuff. Let's start with 1 minus cos of 2 theta divided by the sine of 2 theta. We are being told that we need to prove that the 1 minus cos 2 theta divided by the sine of 2 theta, we need to prove that it actually equals to the tan of theta. So on these questions, the most important thing is to know the basics. The best way to build a house is to know how to lay a brick, right? So don't just go there trying to build a mansion without knowing how to lay a brick. And it is there where you can build any kind of house you want. Same thing with these things. Don't just rush to solve the complicated questions. Know how to solve the not complicated questions, and then use the same strategy to solve the complicated questions. So you have to have some sort of a strategy to answer these sort of questions. Now let's start. We all know that the tan of theta equals to the sine of theta divided by the cos of theta. Why am I saying this? We know that the cos of 2 theta has like 3 identities. We know that the cos of 2 theta, it actually equals to cos squared theta minus the sine square of theta. It equals to 2 cos squared theta minus 1. It equals to 1 minus 2 sine squared theta, right? We know that the cos of 2 theta equals to these things. So you need to have a strategy to which identity you need to turn cos 2 theta into, because you cannot just turn it into any identity that you want. You need to have a strategy to which identity should you turn it to, and which one should you turn it to. Well, you look at that, okay, I'm being required that I need to prove that the left hand side equals to the right hand side. So if I take the left hand side, I find it equals to 1 minus the cos of 2 theta divided by the sine of 2 theta. Now you ask yourself, on tan of theta we have sine at the top. So that is at least what you're trying to do. On this expression, you're trying to bring sine to be at the top. And the formula that only has sine is this one. Don't take this one. It has cos. What are you going to do with that cos? So take this one with the sine, because this one has sine at the top. So at least change this one to be sine. So you have 1 minus. So you're going to change cos 2 theta into 1 minus 2 squared of theta, right? Divided by, what is the identity for sine 2 theta? So we all know that the sine of 2 theta equals to 2 sine theta cos of theta, right? So it means that for sine we're going to put the 2 sine of theta, the cos of theta, right? So we are going to expand this. 1 minus 1 is 0. Negative times negative is a positive. So we're going to have the 2 sine squared of theta, right? And then we'll now have the 2 sine of theta, the cos of theta. So since you know that the sine is actually squared, it means that there are 2 sines, right? And then we know the 2 and the 2 will cancel out. And then again, 1 sine will cancel with this sine, so we'll only be left with what? With the cos of theta. And this is, ladies and gentlemen, equals to the tan of theta, and it is actually the what? The left hand side. Now we can tell that it now equals to the right hand side. So that is how you actually prove this identity. You need to have a method of how you're gonna prove them. You're gonna prove these identities. Okay, now let's actually move into the second question and see how we are actually going to answer it. We're actually now having to deal with 1 plus sine of 2 alpha divided by the cos of 2 alpha, right? And we're actually being told that it actually equals to the cos of alpha plus the sine of alpha divided by the cos of alpha minus the sine of alpha, right? That's what this actually equals to. So we need to prove that the left hand side actually equals to the right hand side, right? So the left hand side actually equals to the right hand side. So which one will we pick? And by the way, it is allowed to pick the left hand side to the right hand side to prove that it equals to the left hand side, and it's also allowed to prove that the left hand side actually equals to the right hand side. I just love using the left hand side, but you know, sometimes you have to use the right hand side, because always choose the most complicated side, because you can always manipulate it to be much easier. But if you take, for example, on this question, you need to take the most complicated side. Let's say on this question you want to take the right hand side, you want to prove that the tan of theta equals to this. How on earth are you going to move from tan to this? Now you're just taking chances. So just take the most complicated side. So at this point, you can see this one has identities. You know, this one has nothing. It has no identity. It has nothing. There's nothing to change. If you take this one, what is the first step? What do you do first? Then why? So now take the most complicated side, because it has stuff you can change, and it has ways you can actually try to move and you know, solve your stuff. Now let's actually take this one. The left hand side is 1 plus sine 2 alpha divided by the cos of 2 alpha. Now let me just bring this page back, because I've written these identities. I don't want to be writing the same thing over and over and over again. So what do we know? We know that the sine of 2 alpha, it equals to what? Sine of 2 alpha equals to 2 sine theta cos theta. So we're going to have what? 1 plus 2 sine alpha cos alpha, right? We're going to have 2 sine alpha cos alpha, and then divided by. Now we realize that we're having this cos 2 alpha here, right? We're actually having the cos 2 alpha. So if we're actually having the cos 2 alpha, now let's look at the right hand side, the bottom of the right hand side. It is at least having the cos of alpha minus the sine of alpha. When you come into your identity, which one is similar to cos of alpha minus sine of alpha? Of course, it is the first option, cos squared theta minus sine squared theta. So here you're going to say cos squared alpha minus sine squared of alpha, right? And then now you realize that, okay, now I've reached the dead point at this point. But at least you are still having 1, because we're having 1 plus 2 sine alpha cos squared alpha minus sine squared alpha. Where do you actually move from here? Change all the identities that you see. What is 1? You know that the sine square of theta plus the cos square of theta actually equals to what? It actually equals to a 1. So you can actually come here and say, okay, I can change 1 to be the sine square of alpha plus the cos square of alpha. It is going to equals to the 2 sine of alpha, the cos of alpha, right? And then I'm going to divide both sides by the cos squared of alpha minus the sine squared of alpha. Am I right? And then you actually say, okay, now where do I move from here? I'm trying to prove that I'm trying to change this into this. Now where do I actually move from here? Now you are having the sine squared and the cos squared, right? There's a lot of squares here, so you know, just use a method of trying to work with something that you're comfortable at. I mean, I'm not comfortable with dealing with sine squared, cos squared. There's just a lot of numbers, but I'm allowed to say, okay, let x equals to what? Equals to sine alpha, and let y equals to the cos of alpha. So whenever there is sine of alpha, I'm going to put x, and whenever there is cos of alpha, I'm going to put y. So what are we going to have? So the sine squared of alpha, because sine is x, I'm going to have x squared plus, what is the cos squared of alpha? Because cos is y, I'm going to have what? At least y squared plus 2. What is the sine of alpha? The sine of alpha is x. What is the cos of alpha? The cos of alpha is actually y, divided by, what is the cos of alpha? The cos of alpha is going to be y squared, right? Minus, what is the sine of alpha? The sine of alpha is going to be an x squared, right? So now you need to factorize this. For me, it's much better to factorize x squared and y squared than factorizing the sine. I mean, like, imagine. So like, at least I can just come here and say, okay, wait, I can just take this y squared and put it at the back of, you know, of this expression, right? I can just take this y squared. I'm just going to take this y squared and put it here. So it means now I'm going to have the x squared plus 2xy plus y squared. That actually equals to a y squared minus an x squared. You know how to factorize this. You can even use the quadratic expression, but you need to be very critical about how you substitute your stuff. But if you factorize this, you're going to have x minus y. Is it minus or plus? No, it has to be plus on both sides, right? Because we are not having a negative, right? So we're going to have x plus y, x plus y. In other words, if you say x times x, you get x squared. X times y, you get x1 times xy, y times y, and then you add them, you're gonna get 2xy, and then y times y, you get y squared, right? So the question is, how do you actually factorize this? So you actually factorize this by y minus x and y plus x. So if you actually factorize this, if you multiply this, you will come back here, right? So you realize that x plus y is the same thing as y plus x. It is the same thing. So this one will actually cancel out with this one, right? And you realize, what are you left with? You are left with x plus y at the top. You will be left with x plus y at the top divided by, and now you are having y minus x, and you'll be having y minus x at the bottom. But you ask yourself, what is x? X actually equals to the sine of alpha, right? So x is going to be the sine of alpha plus, what is cos? What is y? Y is actually the cos of alpha, right? Y is actually the cos of a, divided by, what is y? Y is the cos of a, minus, what is x? X is the sine of a. So you realize that you have actually proven that these things are the same. You can actually say cos of a, we have the cos of a plus the sine of a. You can swipe this if you want, but the point is, you have actually proven the identity that the left hand side actually equals to the right hand side, right? Okay, that one was a bit tricky but simple at the same time. Let's actually go to the following one. Okay, let's have this one. We are being told to prove that the tan of a plus the cos of a divided by the sine of a equals to 2 over the sine of 2a. So you need to prove that the left hand side actually equals to the right hand side. So we need to prove that somehow this actually equals to this, right? So what do? We know that tan of a will have over 1, right? And then the first thing that we do, since I'm taking the left hand side, I'm going to take the lowest common denominator. That is going to be, you times this 2, 1 times the sine of alpha, I'm going to have 1 times the sine of a, right? So in another word, I'm going to say this and this will cancel out, right? And then this will times this. So I'm going to have the tan of a, the sine of a, plus this and this will cancel out. and then this and this will times, and then I'm going to have the what? The cos of A. So in another word, I'm actually having, this is what I'm having. I'm having the what? I'm having the tan of A sine A plus the cos of A divided by the sine of A, right? So I realized that, okay, I'm actually allowed to, okay, what do you think it's the best next step here? Because I do not want to do the same thing over and over and over and over and over and over again, right? You realize that, okay, I'm having 2 at the top and I'm having sine of 2A at the bottom. So how do I actually do that? Okay, let's actually change this tan. We're going to have the sine of A divided by the cos of A times the sine of A, right? And then I plus the cos of A, and then I'm going to divide everything by what? By the sine of A. So now in another word, now I'm actually having the sines sorry, I'm now having the sine squared of A divided by cos A, right? So it means what am I now having? Let me just put it here. I'm now having the sine square of A divided by cos A plus cos A divided by what? The sine of A, right? So what is this actually? What is this? This is the same as having the sine square of A divided by the cos of A, again divided by the sine of A, plus the cos of A divided by the sine of A. So here the sine will actually divide with one sine. So I'm going to have the sine of A divided by what? By the cos of A plus the cos of A divided by the sine of A. All right. So now you ask yourself, well, what do we actually do from this point? Let me try to pull another page. You ask yourself, what do we actually do from this point? I'm just going to copy this. Okay, no need. I'm also going to take the lowest common denominator, right? So the lowest common denominator, I'm going to have the cos of A, and I times it with the sine of A, right? So I'm going to say the cos of A will divide the cos of A. So I'm going to have the sine of A times the sine of A. I'm going to have the sine squared of A plus the sine of A will divide the sine of A, and then the cos of A will actually times the cos of A. I'm going to have the cos square of A, right? So this is what I actually end up at, and now I'm trying to figure out, well, how do I actually move past this? Because now this is actually becoming a very interesting question. How do I actually move past this? Well, I realized that I have actually proven the identity. Why do I say I've actually proven the identity? What is the sine square of A plus the cos square of A? The sine square of A plus the cos square of A is 1, right? And then you divide it by this. You will have like, you can even start with the sine of A, the cos of A, right? Let's end here. Remember, this is the left-hand side. Now, let's go back to the question. If you go back to the question, you realize that, well, this and this, you at least think that they are not the same, right? Are this and this the same? They look like they are not the same. Now, let's actually take the right-hand side. If you take the right-hand side, that equals to 2 divided by the sine of 2A, right? You can actually expand this. You're going to have 2 divided by what is the sine of 2A? You remember that we said that the sine of 2 theta equals to 2 sine theta, the cos of theta, right? You're going to equals to the 2, the sine of A the cos of A. So the 2 and the 2 will cancel out, right? We will have 1 over the sine of A, the cos of A. And this is the right hand side. But you said, wait, and these two the same? Exactly. They are exactly the same, right? So sometimes you need to have more of an eagle eyes into this. And then by that, you have proven your identity. So these things are not hard. They require you to have a lot of practice. Contact the GOAT tutors like myself. I'm just kidding. I'm not the GOAT. I'm the GOAT. Okay, contact people like myself to help you out. But these things are extremely simple. Let's see if there's another question that we can actually try to dive into. I'm actually looking at this. Okay, I saw a question. Let's try it. I believe it will be the last question for today, for this lecture, by the way, for proving the identities, right? Let's have the cos of 2x. You divide it by what? The cos of x minus the sine of x. That actually equals to what? The cos of x plus the sine of x, right? So what is required of us is we need to prove that the left hand side actually equals to what? To the right hand side, right? Now let's go to the left hand side. What is the left hand side? The left hand side, it is actually the cos of 2x divided by the cos of x minus the sine of x, right? Well, if you realize you want to have an answer of cos x plus sine x, and already at the bottom you have cos x minus sine x. This is where you need to be smart. What are the identities of cos 2x? You realize the identities of cos 2x, there's like 3 of them. But which one do you choose from? At least you are looking for cos x plus sine x. Come here and choose something that is identical to your final product. Let me tell you this. This is a real life, I don't know, I call it a real life, I don't know. This is a real life scenario. If you want to go to town, take a route that will take you to town, not a route that will take you to the opposite of where you're going. If you want to contact Marvel to help you, contact me. Don't try to contact someone who has nothing to do with who I'm like. It's like if you want to have the cos of x plus the sine of x, when you change your identities, change them with a variable or with an identity that is similar to your final product, right? So now you're going to change the cos of 2x to be the cos square of x minus the sine square of x. At the bottom, you have got the cos of x minus the sine of x. Remember, my name is Marvel, right? I hate working with cos square of x, and I mean, like, it is a lot to me. I don't want to digest something like this. So what I do is I say let x equals to the cos of x, and you let y equals to what? To the sine of x. This is completely allowed. So what you do is whenever there's cos, you're gonna put x. So at this point, you are having the cos squared of x. It means you're going to have x squared minus y squared divided by what? Divided by x minus y. I mean, like, you can actually prove this yourself. You know that if you factorize this, it has to be x plus y, x minus y, right? Like, that's how you're gonna do it. It is x plus y, x minus y, and you realize that these two will eventually what? Cancel out. And when they cancel out, you are left with what? With x plus y. But the question is, what is x? You realize that x is actually the cos of x, right? And what is y? And y is actually the sine of x. And you said, wait, ain't this the thing they wanted me to prove? That the cos of x plus the sine of x, cos of x, that the cos of x, is blurry. Okay, that the cos of x is plus the sine of x, right? So it is not something difficult. Just go where you need to go. I think we have done enough question or justice for these types of question. So yeah, we'll just now do the general solution questions on the next slide. Otherwise, enjoy the rest of your day.